This problem is based on spectral series of hydrogen. When the electron in the hydrogen atom jumps from an outer orbit to inner orbit, a spectral line is emitted. The ultraviolet region of the spectrum of hydrogen is caused by jumping of the electron to the first orbit, and it is given the largest wavelength of the ultraviolet region 122 nanometer. That means that is this transition from n equal to 2 to n equal to 1. This wavelength emitted is 122 nanometer, longest wavelength because the gap, energy gap, is smallest considering all the other transition. Infrared region is caused by jumping of the electron to the third orbit, and we have to take the smallest wavelength, that means from the last orbit to this. So this is infrared wavelength, what we should find out. The general formula for the spectral transition is 1 by lambda equal to R into 1 by n1 square minus 1 by n2 square, where n1 is the final orbit and n2 is the initial orbit. Okay, now let us write this one. 1 by lambda 1 equal to R into 1 by 1 minus 1 by 2 square, 2 to 1. Simplifying, this becomes 1 minus 1 by 4, which is equal to 3 by 4 R. Let us keep our first equation. Then for lambda 2, let us write for lambda 2 following this. So 1 by lambda 2 R into 1 by 3 square minus 1 by infinity. So it becomes R by 9. Equation 1 divided by 2 gives you lambda 2 by lambda 1, 3 by 4 R into 9 by R. So it is 27 by 4. Substituting lambda 1, lambda 2 equal to 27 by 4 lambda 1, we get 823 nanometer. Answer 2.